Okay, so let's model restriction enzymes and transformation. I have a bacterial plasmid. So this is DNA, you can see the letters here, but it is in a circle. This is what the DNA is like in bacteria. This is a plasmid. And I have a section of DNA from the jellyfish, specifically the GFP gene. So I am going to first take my gene and cut it at the restriction sites or the recognition sites. So notice they're here in bold. So here I have some repeats and here I have some repeats. So I'm going to mark it so you can see exactly where I'm going to cut. So it's the first letter of the top strand and the last letter of the bottom strand. So both of them are going to look like this. So I'm going to cut right there with a restriction enzyme. So the scissors are the restriction enzymes. So I'm going to go through and I'm going to cut. So that I have sticky ends. So when I cut it, it will look like this. And I'm going to do the same thing over here, where I have set it up to where I'm cutting it here and here, or here. Okay. So again, I've made some sticky ends. Okay, so now I have my gene of interest. I am going to do the same thing and cut at the recognition sites on my plasmid. So again, they're in bold, so I'm going to find them. Here it is here. So I'm going to cut it so that I'm on the first, after the first letter of the top strand and the last letter of the bottom strand. So I'll make a mark again where that would be. That's where I'm going to cut it. Now I have taken my plasmid and I've made it I've made it linear because I've cut it, and I have these sticky ends here. And what I'm going to do is, so I've mixed both of these samples of DNA with the restriction enzyme. So I had the DNA in a test tube, and then I put the restriction enzymes in there, and this will happen automatically. And then what I'm going to do is I'm going to put the two together. And when I do that, notice how they line up perfectly here. So AT, GC, TA. They all line up perfectly. So those are going to just automatically go together like this because of that complementary base pairing. Remember, it's like magnets coming together like so. And then on the other end, same thing. So now I have transformed this bacteria. And it has this section of DNA inside of it.